Hello students, welcome to the next lecture on the GATE examination. Today we will discuss about all those questions from the paper GATE 2018 related to this statistics here. Myself Dr. Harish Garg. You can simply follow my YouTube channel and you can scan and join my WhatsApp group for the various shortcut tricks related to the mathematics and statistics. So let's start with this video. Remember always whenever you are trying to attempt any of the statistics questions either in the GATE examination or in the CSR net examination, you have to read the statement very carefully. Each answer of the question is already given in this statement. You have to monitor the statement carefully. So let's start with this one. An urn consists of the 4 balls, which consist of each ball has the equal probability of being white and black. What is the meaning of that? Probability of the white and probability of the black are same. They have the each equal probability. I consider as a here 3 black balls are added. So if you have the 3 black balls you have added, then the probability that 5 balls, if I consider x is my 5, are black. So if I consider x is my number of the black balls, so what is the probability of that? So now you have to find 5 black balls from here. You can see out of these 5, 3 are already known to us, that they are exactly 5. So basically you are trying to find the probability of x3 out of these 4. Out of these 4 you are trying to find the probability of 2 number of the black balls. Fine. Now that's over. Now you can think about that. These are the how many maximum number of the balls? 4, which is a finite. So you can see if I write here n is equal to 4, which is finite. What is the probability of the black balls? What is the probability of the black ball is half, which is a constant. So which distribution is applicable when n is my finite? You can see there is a binomial distribution. Remember, whenever n goes to the infinity, then you have to apply the Poisson distribution. But here n is my finite, so which is a binomial distribution. Now apply the binomial distribution here. N is my 4, x is my 2, probability is my half, and half of n minus x. So what is the 4c2? It's a 6, it's a 1 over 4, it's 1 over 4. So it's 6 over 16. So 6 over 16 is nothing but my 3 over 8. So you can see the right answer is my B is the correct answer. So remember, you have to write the whatever the statement given to you, you have to write in this question and you will get the right answer in very simple. Look at the next question. X and y have the joint density function which is given to be here. Fy represents the marginal distribution of y. So what is the f of y? Which is collection of all those x here. Now you have to take the limit. You may take the limit as from here, but I not always recommended you can take the limits from here. Always draw graphically firstly, and then you will get the best answer. X is 0, this is my x is 0. X is 1 minus y, means x plus y is equal to 1. This is the line of the x plus y is equal to 1. Y is equal to 0, y is equal to 1. So which portion is? This is my shaded portion. Fine, this is my feasible region. Now in this feasible region you have to find the limits of the x. You can take the horizontal strip. This is 0. What is the, well, this is the line of x plus y is equal to 1. What is the value of the y x at here? It's a 1 minus y. So it is my here. Remember, this is the example where it is already given to be here, but it is not always true. Like if you write like this manner, then what is the limit of the y? Can it be 0 to 1 or x to 1? You have to write from the graphical. So what is that? It's a 2. What is the integration of this is? So this is a value of f of y. Now they need the f of half. What is the f of half? Which is come to be 1 is the right answer of this problem. So remember, within a fraction of second you can solve this question in a very easy manner. Let's think about the next question. Now first of all, whenever there is a CDF, this is my CDF, then the probability at a single point, it can be 0 or it can never be 0. when it will be 0? It is 0 only when your random variable is my discrete, and when it is a continuous, then it is not a 0. Fine. So now you can read about this statement, because we all know probability at a single point is 0 when it is a continuous random variable. Sorry, that's I reverse that. This is a non-zero when it's a discrete random variable, and this is a 0 when it is a continuous random variable. Now look at that, whether it is given to you that it's a discrete or continuous. It is not given to you. Fine. Now how you check whether it's a discrete or continuous? You have to find the left limit of the CDF. You have to find the, let's say, x positive and say x negative, right hand side limit of this. If both are same, then we call this as my continuous. Otherwise we call as a discrete. So look at the breaking point 0. What is the right limit is 0. It's same. Look at the 1. If you look about that, the right hand limit is my 1, left hand limit is my 1. It's again the same. Look at the half. The left hand limit is my half, right hand limit is my of this. Now you can see which is not equal to half. It means this x is my discrete random variable. Fine. So once it's a discrete random variable, this answer will not be a 0. Clear? How you can find that? So remember the second tips for you always. What is the probability at x is equal to a when it is a discrete random variable? You can write this as f of a minus f of, I can clear this screen, f of a minus f of a negative. So what is that? This is f of a is my half, because we need value half, minus f of half negative. Half negative means limit at a negative. So what is the value of the f half? It's equality here. So what is that? It's 3 over 4. What is the half negative? Half negative is my here, so it is my 1 by 2. So what is the right answer is 1 over 4 is the right answer. So 0.25 is the correct answer of this problem. Remember, this is a very beautiful tips for you. You can find this in manner. For example, in this question, if I call what is the probability at x is equal to 1, and you can see at x is equal to 1 is a continuous, because the right hand side limit is 1, left hand limit is also 1, so you can directly write as a 0. Otherwise you can again use the same approach, f of 1 minus f of 1 negative. What is f of 1? You can see the last limit, right and left limit is my here, which is my 0. Otherwise you can simply use this concept. It will be 0 when it's a continuous random variable, otherwise discrete. Moreover, if this question can be asked you like of this manner, what is the probability x less than of 1 by 4, for example, then remember it is not equal to f of 1 by 4. Remember, it is not equal to. Why? This if you remember, you have using, I think you are using this equation for finding this one. But remember, this result is applicable only when x is my continuous random variable. But here this is not a continuous random variable, so you can never write this in terms of here. Then how you can write that? Again, a very simple concept is, you have to look about 0. 1 by 4 is lies here. 1 by 4 is lies here. How many breaking point in this case? There is only one breaking point, that is my 0. So that means this is nothing but my x is equal to 0. How you find x is equal to 0? So f of 0 minus f of 0 negative. For example, once more, if somebody asks you that you can find the answer of this, again this is not a continuous, so you have to write probability x is equal to 0. 3 by 4 lies here. So another breaking point is my half. Look at only at the breaking point of this. Then how you write f of 0 minus f of 0 negative plus probability x is equal to half, sorry, probability x is equal to half. How you write the probability x is equal to half? That means it is nothing but f of half minus f of half negative. Now what is the f of 0? 0 equality lies here. This value will be 0. 0 negative is the 0. F of half is my 3 by 4. F of is my here. So whatever the answer you can got is the right answer of this problem. So remember, this result is only applicable when x is my continuous random variable. You can see also my previous lecture which I have described here in my playlist, gate statistics, where you can see the question is related to the CSAT June 2023 Markov chain. You can see this gate 2017 paper. You can also see the complete solution of the statistics CSAT 2022, as well as the complete gate statistics solution of the year 2023, 2022, even 2021, 2019 and many more in my gate statistics playlist. Now let's see another question here. Now again read the statement carefully. Xj represents the independent and the Bernoulli distribution with probability here. So remember, whenever you have the Bernoulli distribution, you have the two random variable x and, so probability of this is my 1/4. So can you find this answer? Is 3/4, such that y of n is my half summation of xj square. Can I write this quantity in terms of here? Fine. So yn is nothing but my here. Then yn is convergence in probability to 1. Fine. That's a very simple. Remember, you have to apply the definition of convergence in probability, or you can apply the definition of the center limit theorem, or you can say the Chebyshev inequality. You can apply the Chebyshev inequality, but convergence in here, this yn convergence is to the mean of xj square, because yn is the average of xj square. So yn converges to the expected value of the xj square. How you find the xj square? That is the variance of x square plus expected value of the x whole square. Fine. So how you can find that? So what is the expected value of the x from here? This is a 0, it is 1/4. Otherwise you can find directly as a e of x square into probability mass function. So it's a 0 square into 0, 1 into 1/4. So the right answer is 0.25 is the right answer. Another method, another way how you can solve that, I can write for you here. Say how you can write that. We all know x follows my Bernoulli. Fine. So what is the mean of the Bernoulli distribution? That is my p. Variance of the Bernoulli distribution is pq. Fine. If you remember, what is the mean of the binomial distribution? Mean is np, variance is npq. If you take n is 1 here, then it will be good. So then how you can find the e of x square? This is nothing but my pq plus of p square. So again you can see p is a common, q plus p plus q is my 1, so it is my p is the right answer. So that's again the same manner you can do in a similar way. Otherwise you can substitute the value of the p and q here, you will get the answer as same answer. Okay, look at the next question. xi is the sequence, again these are the independent. xi is the sequence of the Poisson distribution with the parameter here. So what is the meaning of that? The mean and the variance of the Poisson distribution are always same and same as that of the parameter. Then Wn is defined as of this value. So what is the meaning of that? This is nothing but expected value of xi, that is a x bar. Fine. So basically x bar is nothing but my Wn. That's the meaning of this. Then the zero mean, and the variance of the limiting distribution of this is a normal distribution. Fine. What is the x bar? It is always give you a normal distribution with mean here and sigma square by n. Fine. Then your target is to find to be here. So this is basically w bar. Fine. Now there are the two methods. Firstly, you can find the mean of this and check whether it's a 0 or not. If I find the mean, so root n is outside of here. So what is that? Root n is outside. What is the mean of the w bar? It's a mu. Mean of the lambda is my here. So that's a 0. it's satisfied. How you find the variance of this quantity? So n root n is my n is outside, so variance of wn minus of this. So we all know the constant value variance is 0, so variance of wn. So what is the variance of the wn? You can see sigma square, that's a variance of n. So that's answer is lambda is the right answer of this problem. Otherwise you can find, there is no need to find of this, you can directly write the variance of this. So what is that? It's again n is outside, variance of this. So variance of this you can find it as 1 over lambda over n is cancel out, so again lambda is the right answer of this problem. Let xi is the independent and identically distributed, that is IID. Fine. Okay, so what is the meaning of that? Each having the mean same, variance is also same for the each random variable. So what is the variance? We can see x bar is nothing but my sample mean. Then you have to find the ML. That's fine, that's very simple. You have to find the L firstly. Fine. So that is a probability density function of this. So what is that? If you take the product of this, it will be theta raised to power n into e raised to power minus summation of theta times x minus 1. Now take the logarithm so that your calculation will be simple. So n log of theta minus, it will be outside, and xi minus 1. Fine. Now for the maximum likelihood estimator, you can take the first derivative 0. So it give you n by theta minus summation of xi minus 1 is 0. So can you find the value of theta from here? It is, if I open this bracket, it is summation xi minus n. Now all are in terms of the x bar. This is x bar. So I can divide it and multiply by n. So if I divide both sides by n, it will be my x bar minus 1 is the right answer of this problem. So again, now you can see the very simple, you can do it a very simple manner in this way for solving this problem. Okay, look at this another one. What is given to you? Again they are independent. Xi's are my independent, which follows the exponential distribution with the parameter, okay, with the means are there. Okay, firstly I will give you the tips for you. Fine, that's a very simple, because you have to find the, this is nothing but my order statistics. Fine, this is my ordered statistics of x1. I already gave the shortcut tips in my previous lecture as well, but anyhow, what is the tips for you? Remember, whenever xi's are exponentially distribution with the parameter lambda, then the ordered statistics x1 also follows the exponential distribution with the parameter is lambda I. Fine, that's very simple. Now you can read the statement. Remember, this is the mean. So what is that? X1 has the mean 1. So remember, if x follows the exponential distribution with parameter here, then what is the mean of the exponential distribution? 1 over lambda. All of you know that. So what is the meaning of that? In this case, what is the lambda? 1. It is my 1. X2 has the mean 1 by 2. So what is the parameter of this? Is my 2. Similarly, for the x3, it has the mean 1 by 3. What is the parameter? 3. X4 has the mean 1 by 4. So the parameter is 4. Now according to this rule, x1 is the order statistics of the minimum, which is nothing but y. It is the exponential distribution with the parameter sum of this. So what is that? 4 or 3, 7 and 10. Fine. So once the exponential parameter is lambda, what is the mean of this? So the mean of y is my 1 over 10. So the right answer is my 0.1 is the right answer. So you can see, with the help of this shortcut trick, you can solve this question within a 10 seconds if you know the right answer very much. Okay, look at this another one. X is the number of the heads in the 4 tosses of the fair coin. So what is the meaning of that? Is a fair coin, probability is my half, or by the person 1. Y is the number of the heads of the, again the 4 tosses of the fair coin, by the person 2. all the tosses are my independent, then you have to find the probability x is equal to 1. Very simple. Firstly, think about that when x will be y. So either both are same to be 1, both are same to be 2, both are same to be 3, or both are same to be 4. Fine. So I can write this number as in this manner. X is equal to y is say k, where k is either 1 or 2 or 3 or 4. Fine. Now I can write this expression in this form also. X is equal to k, comma y is equal to k. Fine. There is no problem, where k can be any number. Since they are independent, so I can write this number as x is equal to k, y is equal to k. Fine. So what is that? Now what is that? X is number of that is a 4 tosses. So n is my 4, which is again a finite. Probability is also finite. So which distribution you can apply? Again you can apply the binomial. So what is the binomial of this? 4ck, probability is half k, half 4 minus k. This is the probability of the x. So since y has also the same, so we can say 4ck, half of k and half of 4 minus k. So what is that? What is the right answer is 4ck square. Half of this is will be cancelled out. So half of 4 is 16 into 1 by 16. So it is a 1 over 256 4ck of whole square, where k is my either 1, 0, 3, sorry, it's 0 also, because it's a binomial. Binomial can be 0 also. So 4. Fine. Now you can substitute the value of this. So 1 by 256 is outside. So it is my either 1 or 2 or 3. So it means they are my disjoints. So you can add them. When k is equal to 0, 4c0 square plus 4c1 square, 4c2 square, 4c3 square, and 4c4 square. So what is that? 4c0 is 1. It's a 4. It's a 636. It is my 16. It is my 1. So divided by 1 by 256. What is that? It's a, what is the right answer is 36. It's a 32 and it's a 2. So 40, 70. So the right answer is 70 over 256 is the right answer. You can write them in the 3 decimal places. You will get the right answers in a very simple manner. So let me find it in on the calculator. 70 divided by 256. So the right answer is 0.2734. You can write into the 3 decimal places. So 0.273 is the right answer of this problem. That's a very simple answer of this question. Okay, look at this another one. So x1 and x2, again they are independent and they are geometric. Remember, what is the geometric distribution is p q of x minus 1, where x is my 1, 2 and so on. That's the same thing it's given to you. Now they are talking about this conditional probability. Okay, that's very simple. Remember, very simple tips always given to you whenever there is a question related to the conditional probability. Fine. Firstly, you have to evaluate the p of b. Always evaluate first, and then we will look about the a from the b. For example, what is that? x1 plus x2 is equal to 4. Fine. And x is my start from the 1, 2 and so on. So what are the possibilities of this? x1 can never be 0, x2 can never be 0. So first pair is my 1, 3. Second pair it can be 2, 2. Third pair will be my 3, 1. x1 can never be 4, because if it is a 4 then it is a 0, which is not in the domain. So there are the 3 options for you. Fine. This is the portion of the denominator. Now look about a look from the b. A look from the b. What is the a is? x1 is equal to 2. So this is my numerator. Fine. So what is the right answer of this? That is the probability x1 is equal to 2, x2 is equal to 2 divided by the total of this. This the first answer, second answer, third answer. That's a simple way. Now how you can solve that? Because they are my independent, So if I write the simply x is equal to 1, x is equal to 3. Once they are independent, you can write this as a x1, x3. Fine. I can written this as a q. So what is the right answer of this x1? It is nothing, simply p. X is equal to 3. This is my here. So that is a p square q square. So the first pair answer has p square q square. When you substitute 2 comma 2, for the 2 it's a p q. Second is also p q. It's a p square q square. For the third one, 3 is a p q square. When you take 1, it's only the p. So that's a p square q square. So what is the right answer? The numerator will be my here p square q square divided by the sum 3 p square q square. So the right answer is my 1/3 is the correct answer of this problem. So that's a very simple target. You can solve this. Remember always, whenever there is a conditional probability, always look the B firstly and then find the A from the B. So again, if I give you some another example, let's say if they ask you find x1 is equal to 3, condition x1 plus x2 is equal to 4. So firstly, you again find the cases of this. Again they are here. Out of these 3 cases, which one is the x1 3? This answer. So what is the right answer of this question? Denominator is this answer as a p square q square. All have the p square q square. So addition will be 3. What is the right answer of this is p square q square. So again the right answer is 1/3 is the correct answer. If somebody asks you find x1 is equal to 4, okay, then how you can solve that? Firstly find this. There are 3 cases. Is there any case about x1 is equal to 4 in this case? No. So it means the numerator will be 0, denominator is 3 p square q square. The right answer will be 0. So that's the way you can solve that in a very simple manner. So this is all about the GATE 2018 questions. You can simply scan and join my WhatsApp group here, and you can simply like, share and comment on my videos. We will solve the next questions related to the GATE 2019 and the others are there. Best of luck students. Happy learning.